Welcome to Lab 2, where I will talk about some of the forces that are acting on a falling object and how these forces affect the fall. In this lab, I will demonstrate the acceleration principle, also known as Newton's second law of motion, which states change in velocity divided by change in time equals final velocity minus initial velocity divided by final time minus initial time. I used a Nerf dart for my system. I dropped it from rest. It is traveling in the negative y direction. The axis is tilted due to some wind. The forces acting on the system are gravity, which exerts a constant force of 9.8 newtons a kilogram, and drag, also known as air or fluid resistance. Drag is a variable referring to forces acting on a solid object moving through liquid fluid. When drag and gravity equal each other, the acceleration stops and velocity becomes constant. The curved line demonstrates that dart's acceleration. Newton's second law states that if an object accelerates, net force does not equal zero until motion is constant. I changed the mass of my system to 0.00025. The velocity vector is set to 0, 0, 0 because it has no initial velocity since the dart is dropped from rest. The time step is 0.001 seconds because the motion lasted for 0.467 seconds. This model has no drag because I programmed it to zero drag, but the blue arrow is not programmed out. So as the dart accelerates, the arrow gets larger. Now I uncomment the drag force and run it again. With the drag force, and the arrow does not get as big as it did earlier because the drag force is calculated in. This is a graph of the system blue line with the drag and gravity against the computer red line with no drag affecting the object. This is a graph of the system blue line and computer prediction red line with drag and gravity affecting the object. I think it is off because of the wind creating turbulent air, making the drag greater on the dart than in the computational model. What does it mean? This graph has drag and gravity forces and looks like the computer red line has terminal velocity starting at 0.2 seconds while the system blue line starts at 0.3 seconds. This graph has no drag and does not have a terminal velocity because there is no drag, therefore drag force and gravity force cannot equal each other. For the what if question, I changed the velocity vector to 0, -50, and you see that the drag force arrow is large and then shrinks until it equals the gravitational force. This is a graph of the system blue line dropped and the computer model red line thrown with a velocity of 0, -50.